evening, ladies and gentlemen. My name is Dominic, and I welcome all of you for today's webinar presented by DURANC on Computer Vision and Analytics Industry 4.0. It's a completely different topic what normally we do on the subject of video management software. So most of us must be wondering, what is Industry 4.0? 4.0 is also known as the fourth industrial revolution, referred to the integration of advanced technologies such as artificial intelligence, the IoTs, cloud computing, the big data analytics into the manufacturing process, create smart factories and smart systems. It helps to create more efficient, flexible, and responsive production system by using interconnected digital technologies to automate and optimize manufacturing process. That is Industry 4.0. And today's topic is about computer vision, how computer vision can play a role in Industry 4.0. Computer vision is particularly important in Industry 4.0 because it enables machines and systems to see and interpret visual information in real time. This ability is crucial in various manufacturing processes such as quality control, defect detection, and predictive maintenance. Today we are going to talk more about computer vision in Industry 4.0. This particular webinar is presented by DURANC, India's leading video management software development company. Every month they have been running a series of webinar on various aspects, how VMS can play a role in construction industry, warehouse, retail, attendance management. There's so many, so and so on. So today I'm happy to present DURANC. DURANC vision is to help businesses and organizations maximize the potential of their surveillance of camera. You all have CCTV. CCTV is in everywhere, whether it is on road traffic, whether it is in residential building, commercial building, hospital, healthcare. You have CCTV everywhere. How efficiently are you using these cameras? Is it used just to see the images, or do you want to advance what you see is into analytics, get exactly the information that you want? That is a video management software. So to do this, they have built a secure and reliable cost-effective video platform that provides users with deep intelligent analytics and insight in real time. They founded in 2014. They gathered a highly talented global team to create cloud-based platform. DURANC innovative video streaming and storage technology offers clients the ultimate in video surveillance functionality delivered seamlessly from the cloud. They have headquarters in Nashville, USA. They have R&D in Finland and development global support in Hyderabad, India. I'm very happy to say, since last year, DURANC is scaling up their development activities, scaling up the use cases. And today, the most sought after VMS company in India. You look at mining, you look at process industry, look at automation. DURANC is the most advanced video management software that you can look at it. I'm also happy to present, I've already introduced myself. There are two speakers today who are going to speak on this subject. Mr. D.P. Sreenivas, who is the CRO of DURANC Tech Services. He's a co-founder and CRO of DURANC, the leading provider of VMS analytic as a service. He has been instrumental in shaping product design and features and market insights. Being ferocious reader and extensive traveler, he is a strong believer in the concept of innovation ideas coupled with strategic implementation and commercialization lead to create of jobs and wealth. His mantra can lead corporate India to become world economic leader. That is Mr. Srinivas for you. And have another speaker, Mr. Vamsi Krishna, who's been the face of video management presentation. He's been traveling around the world, especially traveling around India in every market segment. He's doing his best to make sure that people understand what exactly VMS is and how VMS can transform their business. He has extensive experience in dealing with cross-functional teams and customers across the globe, including US, Europe, South Africa, and Middle East. With strong focus on quality, he spearheaded the implementation of ISO 9001 and 2015 and ISO 27001 for product development and technical support process within the organization. As a technical evangelist, he advocates and helps customers benefit from and understand the limitation of the technological innovations in the surveillance industry. So, ladies and gentlemen, today we are going to take our valuable time, being working day, and Saturday there is Eid for a few people, a holiday coming up. And I wish, we could have done much better crowd attending this. Nevertheless, those who are attending, I'm sure you will benefit from the presentation of Mr. Sreeni and Mr. Vamsi today. So I welcome Mr. Sreeni and Vamsi. Sreeni, are you there? Is he coming on screen? Vamsi?
Yes.
Okay. Yeah. Hi, Vamsi. I'm sorry. I know you had some technical glitches in joining. Today, I hope nobody, as I know, in the VMS industry in India, nobody has covered this topic on Industry 4.0. And I'm sure as you are taking the lead, specifically on automating the whole process industry, let's see what is there for all the participants who's listening to you. Over to you. Take it forward from here.
Yep. Let me thank you, Dominic, for putting up these series of webinars to help us connect with the required customer base who needs to get some information and input of the R&Ds that we are doing. And also a quite interactive way, we get the feedback from our customers to really, which help us in shaping us our R&D in developing the technology. I thank everyone participating. Thanks, Vamsi. See, the topic as such is a very high in the vision of every industrialist, every industrial house per se. Okay, so the primary goal of the Industry 4.0 is connecting everything that actually operates in the shop floor, operates in the factory, outside the factory, with inside the factory, and making the every data point to be used perfectly for the purpose of process improvements, cost reduction, and also the safety of the human and the robotics that are actually coexisting in the Industry 4.0. So having said that, every kind of a technology, whether it is IoT devices, which are bringing the sensors data, or the robotics that are spitting out a lot of data, the process data, the inventory data, just-in-time manufacturing process, all these coupled with computer vision can actually make it much more better in terms of its improved process for the future of the industry and also future of the entire economy and the people of the world. So that's where we are also being part of the the Industry 4.0. Having said that, computer vision is not given its due kind of like respect so to say, in the industry 4.0, right? Most of the people talk about IoT and the data that is coming out of the sensors, the data that's coming out of all these interconnected devices. But the visual effect and the data that is collected from the visual information, that's actually exponential, and that can actually make a lot more advantages. Having said that, I'll ask Vamsi to take it forward.
Yeah, thank you. Thank you, Sreeni. I myself have a lot of questions. I'm sure participants do have a lot of questions to ask you. Let's make this program more interactive. I would request all the participants who are there. There is a Q&A box down. You can see there's a Q&A. Put all your questions. Let's understand. Let's take these next 45 minutes, 1 hour to gather information, enhance our knowledge. So post your questions in the Q&A box, so that I'll be able to, as a moderator, I can take your questions. And I myself have questions, so I will come back to you. Over to Vamsi. Thank you.
Yep. Thank you for the introduction and for the time. So I think as Srinivas was explaining in his brief introduction, the Industry 4.0 refers to the way industry is moving forward with integration of all the systems, the cyber physical systems, as they say. We had our first industrial revolution somewhere around 1780s, with the steam engine being the biggest one, which initiated that. And then the second revolution came up with electricity around 1870s with production lines, mass production, etc., that picked up the revolution. And then the third one by the programmable controllers, a bit of initial levels of automation in the systems with computers and information technology. Now the amalgamation of all these is happening now with cyber physical systems, with IoT devices, with robotic process automations, with machine learning and computer vision technologies. There is now a human machine interaction for overall betterment and improvements in productivity of the operations. So that's where we are at the melting pot of the amalgamation of all these technologies, including robots to AI to computer vision, data analytics, all of that will help the overall industry to move forward in a better way, in a futuristic mode. Now, typically, when we see cameras that are connected, they used to be like everywhere. Always, we see cameras everywhere. And what are they used for? It's evidence management that we know of. So we have cameras. They will be recording. Some incident happens. You go back to check what has actually happened, do some diagnostic work, and figure out what needs to be done. It's evidence management. It's pretty reactive approach. But cameras are witness to everything that happens around. And if we can derive useful information out of that, there's a lot that we can do better. And that's where DURANC has started working on. And that's how computer vision comes into play in Industry 4.0. So cameras are no longer just security or safety. Cameras, coupled with the actual right kind of software with computer vision technologies, can help with everything that goes on in the overall process, whether it is manufacturing, whether it is logistics, pharma industry, all of it. Basically, it will help in terms of ensuring your quality control. It can check for defects automatically, ensure the right parts are correctly placed in the systems when they come out of the assembly line, for example. They can ensure process compliance, whether people are wearing the right kind of equipment when they go into a sensitive area. Are they wearing the right kind of gloves, masks, etc., etc.? All the kit that is required, ensuring predictive maintenance of the systems. So how long a machine is being used, what kind of maintenance is required, based on the incidents that have happened before. You can predict that maintenance activities that comes up in future. You can improve the production efficiency with interaction between the humans and the robots, with data sharing across all the involved items, whether it is IoT, cyber technologies, or computer vision technologies. It can detect anomalies in the systems, whether it is operating robots, whether it is in terms of the functionality of the machinery or the equipment. or in terms of the items that go in the production line if there is any anomaly. We will get into some specific use cases moving forward. We will talk more about that during that point. But all of these help in terms of improving the productivity of overall operations.
Now, so if I may add a small addition to this, it is the fusion of the existing systems that are there, and it is the convergence of the other data points which can be derived from the existing or the new IoT devices, coupled with the vision of the cameras for the same purpose of the quality control, right? So you have the IoT devices giving the heat output or temperature output of a product that is coming out, whether it is a small manufactured electronic component or something, which doesn't need to go, they should not go to certain heat signature beyond. And at that particular point, you need to kickstart the camera data and see whether the process is actually slow or faster, or if there is any anomaly that is actually visually inspected. So those two things combined together, processed and then sent back to the downstream systems to slow down the process or increase the process or reduce whatever is required. So this amalgamation of these two technologies can actually give you the much better opportunity in terms of controlling that quality. So those are the ones which need to be really integrated with the computer vision, along with the cameras, what they are doing. But the camera feed that actually gives much where we are actually implementing the computer vision.
Yeah, exactly. I think when you mentioned the generative softwares, that's where the even product innovation happens through generative design software, which can churn out multiple possibilities. And then the engineers can pick and choose whichever model works best in the real life scenario, and they can choose the right outcomes to suit their needs. We talk about a lot these days, ChatGPT, for example, it's a generative AI model for language. There are generative AI models both in terms of computer vision technologies that we do and also in other spheres of life. Some of these use cases, we spoke a little about quality control. One of the first and foremost points to ensure that the product that comes out is of the right quality. How do we ensure that? Through computer vision, where there are robots doing majority of the work these days in the assembly line. But whether all the items, all the components are placed properly or not, whether there are any parts that are missing, whether there are any parts that are damaged, for example, all of that can be detected through computer vision. There is no other way in which you can detect. IoT will not help there. A robo will not help there. It's the computer vision that comes into the play there. So that's where the technology amalgamation is required. You use all of these available tools. The technology is always a tool. So we use the computer vision as a tool to ensure that all the components are rightly aligned and without any damage. There are no missing parts, etc. Through the assembly line when products come out. Another use case is in terms of compliance, ensuring compliance, whether it is in the product development, in pharma industry, what kind of equipment you should have, protective equipment that you should wear, for example, in sensitive areas, specified areas. So in specific areas, you may need to have a specific type of equipment necessary, and that can be checked automatically by the system and alert, take necessary precautions, because it could be a hazardous environment, and without a right kind of a mask, you should not get in there at all. So that avoids or prevents incidents, fatalities, etc. by using the right technology in the right area.
Not only that, these are all zero dust rooms, some of them. And what the use cases we are getting is, like, if somebody is missing the PPE kit or some kind of a mask, it actually contaminates the the output of the product that is produced there. So are we specifically monitoring them, inspecting them, and then sending the downstream systems if there is any violation or if there is any anomaly? Apart from that, if there is a set process that need to be followed, that step 1, step 2, step 3, and if your staff or if your employee is missing one of the steps, then obviously, that's a big, red flag that you need to, immediately alert someone. So that process fixing also can be done through the computer vision, and those process flows can be adhered. And once that is adhered, then, as a compliance, you can check mark and send it to the it actually takes it to the next step and say, yes, the entire steps were followed. So the product produced is as per the compliance. So those are the ones that are, very, very high in the terms of usage for these kind of a pharma environments.
Yeah, and another use case is in terms of detecting the anomalies, as we were talking. If there is a missing component, for example, if there is a malfunction in a device, visually the system can check if there is a malfunction, it's not operating properly, whether it is IoT device or a robot that's not operating properly. With the computer vision, you can check and alert the right team, and that immediately can be taken, corrective action can be immediately taken. That's one example. We have another use case in manufacturing facility, wherein sugarcane is placed on put on the feeders and goes into the conveyor belt through into the crusher. If there are chances sometimes wherein the logs or iron rods that hold the sugarcane in place, when they are dumped onto the feeders, sometimes these rods also fall along with the sugarcane. And if they get inside the crusher needs to stop for a few hours. It could damage the crusher, or the process gets stopped. In the season, it has to run 24/7 during the season. So it is a huge loss when you're operating it 24/7. So what we have done is the computer vision again comes into picture here, where we deployed the model which can detect any presence of any foreign object on the feeders or in the conveyor belts. Before it gets into a crusher, it can immediately take necessary action. It can even sound a hooter alarm, as well as even stop the conveyor when any foreign object is detected, so that then the guy can actually physically check and then take out any foreign objects that cause damage there.
And there is a continuous workflow in this process where the other systems, which are IoT devices, which automatically kick-started by our system when it looks at the anomaly of foreign object. And those systems also relatively, they will stop our process, slow down, and do whatever the steps they need to take. So this is all, a fusion that goes in terms of, the workflow.
Then automation in terms of, let's say, for example, we spoke about zero dust environment as an example. If there is any spillage, this is in terms of future pharma production facility, for example, futuristic, where if there is any spillage that happens while taking the vials out, for example, if there is any spillage, the coordinates can be identified through computer vision of where that has happened, and that can be communicated automatically to the cleaning robot, and the cleaning robot can go to that exact location, to that position to clean up immediately without causing any further damage or issues. So it is possible to automate the actions, not just trigger any events or incidents, but immediately take appropriate action, like notifying to another system, whether it is an IoT device or a cleaning robot, for example. So the events that get triggered through computer vision get passed on to external systems immediately on real-time basis for taking the next steps as a process workflow.
So if you see the 3D grid that we have created, that's the shop floor where you have the camera grid that is developed, and each single individual point of that floor can be mapped with the cameras, and any kind of a anomaly or any kind of a thing that can be that is detected there, that coordinates are sent very precisely to these robots, which actually can do the next level of work that they need they're supposed to do. So that grid provisioning of the entire shop floor through the existing cameras or the regular cameras is one of the ones where data can be collected from each individual pinpointed places of the shop floor.
Then we also need to ensure, as we said, it's IoT, humans, robots, everything working together. And we need to ensure the safety of all the workers on the floor. Like, for example, whether it is the case of rail guided vehicle that's on the move to ensure there is no pedestrian walking across the track or near the track to avoid incident, or whether it is the forklift that's moving at a set speed, and if it is traveling at X amount of speed, then the distance from a pedestrian should be Y. For example, if the forklift is traveling at 15 kilometers per hour, the distance from a pedestrian should be minimum 15 feet. If it is traveling at maybe 5 kilometers per hour, the distance could be even lesser. So there is also a combination of parameters. What is the speed, what is the distance? Based on that, the system can calculate and track trigger events. So we are not only tracking the actual events when they happen, the actual accidents that they happen, but also the near miss incidents to ensure we can track all these near miss incidents. Where was the possibility for something to have happened, and you track it over a period of time and take appropriate action, whether it is rerouting or whether it is modifying the standard operating procedures, etc. So we track also those such near miss incidents. Another example is if there is complete view blockage on a forklift, for example. So all of these scenarios are from a worker safety perspective to ensure that there is the environment is safe and secure for all the people inside. Computer vision can also help in terms of inventory management to automatically track the movement of goods from place to place, from a different location, etc., making it easier to monitor the inventory levels, and it can optimize the logistics processes. It can also detect any anomalies in between. For example, when the goods are getting moved, if it stops in the middle, for example, for any reason, then automatically it can be detected through computer vision. The system can detect and alert that the flow is stopped there. So you can detect the movement of goods and any hindrances in the movement of the goods.
So there are use cases where right now all these automated robotic movements that are there in the packaging, delivering, deploying in terms of picking up and delivering in the warehouses. There are a lot of times there are items that are falling from conveyor belts or items falling from the shelves. Those are kind of like blockages to these small robots. Existing cameras with the computer vision, all these anomalies are critically evaluated and then immediately informed to do the responsive team to clear those paths, clear those obstructions. And that also, as a data point, we can take it and then send it to the other systems to slow down. See, video analytics as such, in terms of grabbing the data through the video and sending that as an API to number of these systems is what actually makes them interact with each other. If you are communicating to other system, and if each individual robot or the set of robots are getting connected through the computer vision data, then you have much more advantage in terms of controlling factor for all these operations to go in smooth way. Not just the sensors, not just the infrared sensors, not just the alert mechanisms from one to the other, but the data from the visual is much more impactful, much more effective in terms of taking real-time scenario and then sending that real-time data into other systems where they can actually react by taking those data points.
Yeah, this is the real-time visualization and alerts that can be taken up, because as we said, it's the cobot environment where collaboration between the human and the robot processes that are intermingling, and collaborative environment for production. So real-time data can be captured through computer vision.
Yeah. So in this kind of a scenario where there is still a combination of not fully 100% robotic manufacturing is happening, but there is a combination between humans and robots working together. The movement of the material, say a simple example of raw material that's taken in a paper industry kind of a scenario where we have done some testing. If the material is moved from a point A to point B, which is actually a just-in-time requirement as a raw material, all the connected cameras can actually monitor them and then set an assessment of the time that it's going to reach to the other side in seconds and minutes. So that's an input data that actually can be used for the purpose of whether there is a delay in this movement of the vehicle, where if it's breakdown or if it stops, then the raw material is not coming to the machine in time, right, for the loading purpose. So those are the ones that actually can be utilized through computer vision and with all the connected cameras, and then send the data to the downstream systems.
So overall, how computer vision helps in the fourth industrial revolution is by having a single sign-on system for all managing of all your visual data points, basically from all the connected cameras that you can see as a consolidated view. Whether it is one location, whether you have multiple locations, it's possible to centrally connect all those locations for a centralized command view. Then we have automated inspection through artificial intelligence, AI, which will result in the correct data that you can capture immediately on real time and ensuring your safety and adherence to standard operating procedures, etc. The immediate triggers that help, along with generating visual alerts or even audible alarms, etc., that can be triggered based on the set criteria on the camera positionings. You can do a lot of resource optimization, both whether it is human resource optimization, the process optimizations that you follow, positioning of the equipment or realignment of the processes. All of that can happen through the events that get generated over a period of time, and by doing a trend analysis over a period of time in terms of what kind of incidents have happened, what kind of data points that we saw before, and do a predictive analysis to optimize your further processes. So how does computer vision come into picture from where we were talking about in terms of those specific use cases? How do we integrate those into one platform is what we talk about in ensuring the smart factories or smart warehouses, etc. So the first point is to be device agnostic. So whatever existing cameras should be able to connect. There should not be any need to have to reinvent the wheel or replace all the existing cameras to be able to do these functionalities. So that's the core of the solution that we need to deploy. So existing cameras should be able to connect, and the computer vision should function on those cameras and provide you the events and alerts and all these use cases that we spoke about. So nothing specific required from any particular camera, and it's connectable using any type of a network. You may have Wi-Fi, wired network, broadband kind of a connection, whatever be the network connection, all of that should be able to connect to the central platform. Then, irrespective of the number of cameras, number of locations, with the ease of use, no matter now as the technology gets complex, more and more complex, the user interface should go the opposite way. It should be more simplified with every iteration of the technology that gets complex. So that has been the focus for us, and all the interface has been simply browser-based without any requirement of any additional even plugin on the browser. Simply directly on the browser, the user, even a layman who is not tech savvy, can actually operate and see the events and take the next actions and see the workflow. So that's the important aspect of usability. Then security, definitely, because now we have a lot of systems interconnected, and security is at the core of the entire solution, of any solution that we deploy, because there is a lot more now riding on the interconnection of all these objects and IoT devices, etc. So end-to-end encryption is must to have when you're interacting with either within the system, intra-system, or inter-system communications. Then all of it is enabled through the computer vision, the AI-based analytics. So the cameras are the ones that are providing the feed, but whereas the analytics are run through the computer vision, the neural networks that are built to cater to these specific use cases for a specific environment that are developed and deployed for that scenario. And then APIs, which are most crucial, because as I said, as we have been talking, it's an amalgamation, it's an interconnectivity of all types of equipment and products. So we need to have whatever data point that gets generated through computer vision, for example, should be immediately go to, let's say, the other system, like the cleaning robot that has to go. Or the one data point that comes from a robot that's moving that gets stopped suddenly, that data point should automatically flow back here to another system for rectification. So all this data flow is enabled through proper APIs in the system.
So just to add a point to what Vamsi said about the connectivity, Industry 4.0 specifically defines a lot more emphasis on the cloud processing and data location in the cloud. The reason being there are multiple factories working together, not just one location, but the data that is coming out of the one factory is actually is needed for the other factory in a different location. Whether it is the output that is coming out so that it is going to be sent to the other factory, whatever the use case may be, but these are all interconnected factories now, and they rely on data between them. So the cloud emphasis, when it comes, you need to have a lot of data that goes into the cloud that need to be transferred and managed between the systems. One of the things that what we have seen is cameras with a lot of AI intelligence is been built, but most of the times they are very hard on the edge side, and you get a lot of limited opportunity to do limited kind of a system process on those cameras, and they are kind of like one single functionality kind of cameras. So what we do is we take any kind of a camera that is there which is giving the feed, and we do the process of analyzing the data locally on the prem, which we call near edge, or we push that data into the cloud and do the full analysis in the cloud itself, and then transfer the data to the other systems through the cloud. So the enablement between these cameras to the cloud, and then processing and then pushing the data to the other systems where they are also enabled to cloud. So that kind of an integration where between the systems and hand-holding and handshaking between multiple systems is what is actually the Industry 4.0 defines it. So as to enable the data flow, convenience, and also interdependency on each system to the other system in a very transparent way, right? So that's where our computer vision DURANC focuses on getting the data from the cameras that are very simply, easily deployable. And then based on that video information, we do the analysis and push the data to the other systems that need that information to collaborate for further workflow.
Unlike tracking of any of the systems, with the cameras that are providing the feed, there is a need to ensure that all of them are functioning properly. There is a need to track the health. So now that we are not looking at a diagnostic purposes, but a real-time data generation purpose. So we need to ensure that all these cameras are functioning properly all the time. So there is a real-time tracking of the health of these connected devices, all the cameras that are connected, which are generating the real-time alerts based on the set configuration for the analytic configurations on those cameras. It's easy to see what events got triggered over a period of time through a timeline view. It's easy also to search for specific events that have triggered across locations, specific type of an event across multiple locations. So you see how critical or important that event is to immediately tackle or address. So you have those reports that get generated across multiple locations, either a single location or across multiple locations. Then the ability to define, as we were talking, any camera can be used, and all that is required is the video feed, the live feed that comes. So any analytic can be deployed on top of any camera. Even multiple analytics can be deployed on the single camera as well. So you can have, it is not camera dependent. So you will be able to deploy multiple required analytics, whether it is in terms of checking for the quality check, whether it is checking for the appropriate, whether people are wearing the right kit, etc. So multiple things can be done on the same camera at the same time. And you can also reschedule the events that get triggered. Overall, that's where the value that's added from DURANC perspective is we take the existing cameras, the feed that comes from the regular cameras. So that eliminates the maintenance headache as well. So you don't need to worry what kind of a camera went bad and whether you have to replace with the exact same camera. It does not matter. So all we require is the quality video feed. The live view has to be of good quality. So as long as the view is clear, you don't have to worry about what was the specification of that camera, whether that camera was doing quality check, whether that camera was doing an anomaly detection. You don't have to bother about that. So maintenance becomes much easier in terms of the overall flow. So you have cameras, then you run artificial intelligence analytics on top of it, which generate you live alerts as well as data points for further analysis, which will help you in terms of optimizing your processes, resources, etc. See, overall, when we look at the future of, let's say, manufacturing, for example, it's moving towards the ability to do mass customizations. Consumers now increasingly are expecting, requiring personalized products. A lot of it needs to be personalized. So now when we move towards that, definitely through mass production, it is not cost effective, not time efficient to do personalization at a large scale. But now the emergence of these technologies and artificial intelligence, additive manufacturing, etc., will help manufacturers meet those kind of demands with these automations that are coming up, with the computer vision that's helping. So it makes it one step forward to enable the ability to do the customizations, personalizations at a large scale level. And that's where DURANC also has a role to play in terms of ensuring that making that possible for the future. So what we offer is a platform that is flexible and scalable, not tied to a specific use case, not just a safety, not just a security aspect, but overall customizable solution that you can customize to your requirements, to the specific requirements of the environment, specific requirements of anomaly detections, etc., which works with integrated approach with all the other solutions that are in place, not working in a silo. Because it's no longer Industry 4.0 is not a silo anymore. It's integration with all the data points, and then work as a technology partner, because it doesn't happen in one day. It's a journey. It's a process that we have to follow through and ensure that you have a right partner in getting all the required pieces in place and interoperating with each other, integrating with each other, talking with each other with the right data points, sharing with each other. So that's where we work as a technology partner in the overall solution scenario, not just as one product that is given and then solving one just single problem. The way we see that is we need to think big. It is coming up. It is not a distant future. Industry 4.0 is not a distant future anymore. It used to be. If you see some reports like McKinsey report in 2019 itself, they had a report which said about 70% of the manufacturers are contemplating at that point of time in 2019. Now there are a lot more. There are examples also. We didn't go through in detail, but there are examples of how certain factories are actually implementing this 4.0 and what kind of benefits they have accrued by implementing the Industry 4.0 technologies. We have those reports available. They are available on the net. You can go through as well. So the approach to do is we need to think big. It's not a very distant future. It's coming up and we need to be ready. But we need to start small. We can't swallow more than what we can chew. So we'll have to ensure we take up in a step-by-step based manner, but then we have to scale it faster because the future is coming fast. Yeah, I guess with that, I'll conclude the presentation.
Thank you, Vamsi. I look back in 2000, probably early 90s and late 90s, cameras are just used to just a monitoring device, just as a monitoring device, who's coming in, who's going in, and postmortem. In the early days of CCTV, it is more used for postmortem. But I would tell you, even now, people having 800 cameras, 900 cameras, when you visit some of the large hospitals and all that, there are 3 security guards sitting in front of all this 32-inch TV screen and waiting for an incident to happen. surprising. Some are still in the old age technology. But when you're presenting this, I was amazing, to see how these CCTV images can be converted into, real computer vision, or the futuristic, how it can help the business to grow, or how you can handle the business. It could be retail shop, it could be a processing industry or manufacturing industry. There's so much of development that happened, and I'm happy to say DURANC is far ahead in terms of rest of the VMS. I'm sure they also have, but the way you are putting it across, that you're making it so simple. And
Yeah.
I'm so happy this is also 100% Indian software, and you guys sitting in Hyderabad developing this to improvement of the industry or automating the industry. Really hats off to DURANC in bringing out these informative webinars and technology to the customer. I have a few questions here, ladies and gentlemen, who wants to put a question up to speakers Vamsi and Sreeni. Please post that in a Q&A. I'll just take a very interesting question. Rupa Patnaik is asking, please throw light on robotic process automation through data analytics.
So let me give a little brief before Vamsi go more technical into it. We primarily look at the video as the input, and for us, video analytics is what is converted into data. We don't take the data as such as a raw data from other machines. It's only a trigger points that we take. The rest of it is all analysis that we do on the video analytics, not on the data analytics. There's a lot of data analytics that goes through the industry 4.0. I mean, it is tons and tons of data that's been analyzed by the machines sitting, in the back-end room, and they've been contributing to the manufacturing process a lot. We don't deny that. There are many systems that do work and contribute those. But having said that, our role and our focus is basically visual analytics, computer vision-based visual analytics. That is where our focus is, and deriving data points out of that visual analytics, and then sending them back to the backend systems where actually that can be processed for the purpose of further evaluation and further process improvements. That's what we do.
Yep.
Vamsi, take it forward.
I guess that summarizes it, because we are focusing on the visual data, the data that comes from the camera feeds. That's what is our input, and our process generates the required output, which can be acted upon by the other systems. Like, for example, if we saw dust on the no dust environment, if the computer vision detects that, immediately it can notify to the cleaning robot, for example. So the data is derived from the visual feed that we see, like a human observes, and then that data point is sent for the machinery to act upon.
Yeah. So the other small point I would like to add is there were cameras in the industrial process all the way from earlier days. Machine vision was one of the ones, counting, calculating, and looking at, but they have very low footprint kind of a, performance or particular functionality per se is what they used to do. And these are very expensive and high-end, devices with, high-end lenses and everything, but they go directly deep into the, manufacturing process. But leveraging the other cameras, like the surveillance cameras, which are low cost, but a lot of opportunity is there across the factory floor, and then taking that data and giving back to robotics, giving back to machines, giving back to other IoT devices or solutions, so they can interact and then collaborate. That's what our vision is, or that's what our next steps to do.
Interesting. What you're saying is, so you don't need to build another infrastructure to get to automate this whole process. So the existing the cameras you have, you add your software and get the video analytics to. But wonderful. Let's move on to Mohan Srinivas. He's asking, nice to see use case like falling off object detection from conveyor. He said thumbs up that you can detect that through a camera. He's also asking, we did use edge hardware for our computer vision CCTV computer vision seems to be use cases which we had tried, like Jetson Nano, Raspberry Pi, etc. What is your, what are yours, and from your experience, the best edge software, etc.?
Edge hardware, I think he's asking about the edge hardware. We do recognize Jetson Nanos and Raspberry Pis. Raspberry Pi is a SBC. It doesn't have any graphic interface in graphic cards in that, so you cannot do AI on Raspberry Pi. But Jetson Nano is a low footprint graphic card. You can do a small process that can be done. Look, there are ways of doing the analytics, particularly AI analytics. AI analytics cannot run on very low footprint hardware. If you want to do one single process on a camera, if you have a low footprint graphic card on the camera, you can bind that particular single individual analytic on top of it. But our vision is not that. We don't want to limit ourselves into a small process, bind to a small hardware. What we want to do is we want to be flexible in terms of how you actually apply analytic to a feed, to a process. Like if you have a camera that is giving you the feed, you can do multiple analytics on top of it. If you want to do multiple analytics on top of it, you need to have that particular hardware to be capable of doing it. So that is why we do rely on cloud-based hardware, which is bustable, which is high-end expandable. If somebody wants to do at the on-prem level, right, we do have a combination of hybrid model, which we do perform some analytics at the shop floor level itself. And that is not Jetson Nano. That's actually proper NVIDIA infrastructure that we put there on the shop floor. Do multiple analytics on multiple cameras, or multiple analytics on a single camera. So mix and match, all these things can be done, and these can be scheduled also. You don't want to do an analytic for 24/7 when the robotics the process is stopped. Your analytics automatically should stop. It should know that there is nothing happening on the shop floor after 7 o'clock. Why do you want to do anything, right? So that's kind of like a flexibility we want to create, and that cannot happen with Jetson Nano, which is a very small footprint GPU hardware.
Oh,
you want to take it?
No, I think we have covered it. It's fine.
Okay, let's move on to Rupa Patnaik, API for external integration, a robotic automation process. The question I think Vamsi can answer.
Yeah, API is basically, as we were talking about, when any event is generated within the computer vision platform, the ability to communicate it with the external systems, that's determined by the API. What kind of APIs, what kind of metadata that you share with those systems so that they can process it at the next level. So you would need to transfer the information. Like, for example, if you detect the coordinates of where the spillage was or where the dust was, that coordinates will need to be passed. If there is a robo that stopped in the middle, we'll need to pass those coordinates. If it is a person that is not wearing the right kit, we will need to detect that and probably post the image of that person along with what is missing there, the information of that. So for each type of an event that is triggered, appropriate data will need to be passed on to the next system, the system that we are joining that has to take the right action. For example, in a person scenario, it could be going to the process head or the quality head of the organization with these anomalies. Or if it is the robo that is cleaning, then the coordinates go to the robo. So depending on who is the next level consumer, so we take the input from the feed, process that, derive the data out of it. This data will be sent to the next consumer depending on how they need to consume it, what data points are required for it. So those APIs are provided by the computer vision platform that DURANC built, sending these informations out to the right people or right processes.
Okay, thank you. Thank you, Vamsi. Satkal Mitchell is asking, what is the future of Python programming language? Is something that we can answer?
Interesting question. Probably the only thing I can say is we have seen a lot of languages fly by, like Sanskrit. Now it's gone. The reason is nobody is talking anymore. Nobody can understand it anymore. Same thing happens with computer languages. COBOL, I guess nobody knows now. And even the same thing, like when we were young, we were doing C++. Nowadays, nobody knows C++. It's gone. I mean, so any language is like that. You use it, it will remain there. You don't use it, it's gone. It's not like there are no capabilities capabilities in other languages. Whatever you can do in Python, you can do jolly well in C++. I mean, you can probably do it in BASIC too. But then, there is nobody using that language. It's gone.
So it's a nice academic question, but it's on the lighter side. It's a good question.
Morgan Stream is asking, does video
my
feed?
system?
Sorry, isn't video? Okay. Does video feed into cloud as network issue usually? The question is on network issue.
Okay, you want to take it?
No, sorry. My internet got disconnected. I think I lost a little bit.
Okay,
yeah,
so
the question.
Okay, question says, does video feed into cloud has network issues usually?
Okay. Yeah, as I think Sreeni was touched upon that point a little bit earlier, where the video can be processed on the cloud or at the near edge, which is basically in the on-prem. So on-prem, when we process, there is no dependency on internet connectivity. It's the local LAN. The video feed comes from the local LAN to the processing system, which is basically the NVIDIA GPU servers that we keep on-prem. So that gets processed there, and the metadata can go out to the cloud, and the events will get triggered. The events will remain there in the local network. If you connect it to the cloud, I mean. So then the event metadata goes to the cloud whenever internet connection is established back. Otherwise, if its entire thing is local deployment only without any connection to internet, that model is also there, where the entire servers, everything that's required for the full-fledged operation, the complete 360-degree operations, from taking the feed to sending it to the third party or the external system, everything can be deployed within in the same network and on-prem. In that case, there is no connectivity, external connectivity required at all.
So that's a more proper technical reply what Vamsi usually gives. I like that because it answers the query. But I'll take a little generalized approach on that. See, cloud is becoming more and more essential, and we need to have dependable network connectivities to the cloud. So from the ground to the cloud, what we call, if the network connectivities are not made more robust, that's not our role. That's not the industry's job, the manufacturing job, but it is the job of those network, companies that actually provide the services. And dependency on the cloud is going to grow like exponential. And these network-related reliabilities have to be increased. Having said that, there is still a long way to go, but there is a lot of good work going on in that direction. We hope that year on year these dependencies on cloud will grow more and the networks become more reliable.
The last question, John Oliver, which was the first question. I don't know whether we can understand what is SOP. How does it help in maintaining security?
At a high level, I can just say SOP stands for Standard Operating Procedure. So the set processes that you define to get some work done. So that's the SOP. So how does it help in maintaining security? It's not only security, it's even productivity improvements. It could be even quality improvements, etc. Where everywhere you need to have a standard defined process to follow, operating procedures to follow, like wearing of the safety kits when you're working in a hazardous environment, for example, or not going in groups, or not going closer to the forklift when you are walking. So these are the set standard operating procedures that are defined. So it's not just for the security purposes, but also the safety angle of it, and productivity improvement angle also comes into picture.
Oh, thank you. So we have covered almost all the questions that put on by the attendees. I wanted to just stop sharing. I wanted to share the next session that we will have is on why this. Okay. Thank you all the participants who took part in this, and I think we need to have many more such webinar which can help the process industry. And yes, it has to be much more, need much more participants from the manufacturing industry to come forward. We hope to achieve that in near future. Our next webinar would be on how does the centralized security operations through one single command control. So one platform in real time that can be achieved. So we will be talking on this subject on Friday, the 19th of May, 2023. So we will be sending the invite to all the people who attended today, and in the past, we've been running series of webinars on the video management system, how video analytics can, enhance the performance of the business. So thank you very much. We would love to see you again. Come back, and we will write to you personally. We'll also share this video to all of you. Those who missed it, we will be sending out the YouTube link, and this entire recording will be on YouTube, which you can again go through it leisurely at your convenience. Any message, Vamsi and Sreeni?
That's all for now. Thank you very much for organizing it, and thanks for all the participants also. We'll look forward for the next one.
Wonderful. Being in Hyderabad, tomorrow is Eid. I'm sure you're going to have a good mutton biryanis and what do you call that? Hyderabad Halim, is it? Halim, yeah, very famous. I'm sure you guys are going to rock tomorrow. So good to see you all again. Thank you very much. Have a wonderful day and wonderful weekend with family. Thank you very much. Bye-bye.
Thank you.